Hello everyone. This is the continuation of my previous video. Actually, I couldn't make it how to draw a box culvert from the scratch, but we have done from the culvert itself up to analysis, including the loads applied from the soil and surcharge and the road above. So in this video, I will show you how to draw it from the scratch. For this one, make sure a quick check, make sure your units are consistent. So I'll be using kilonewton meters Celsius. For this one, I'll be using grid only. So if I go there, simply use a cube. For example, in order to consider a cube, you need two grid lines in each direction. In this case, I'll be using two in the x direction, y direction, and z direction. So the same structure I use I used earlier, which is where the link is in the description below, and it was 6 meters in width, and the height of the culvert was 5 meters. So I was using 0.5 meter intervals to draw that. So I'll be using 0.5 meter intervals in each directions. So press OK. So you can see a small cube. I'll get to the 3D view in this panel as well. So it's simply what you need to do is first draw a poly area. Imagine this as the so our XY plane is the horizontal plane and the vertical plane is a XZ plane. So I'm drawing a poly area, this rectangle, and once you select that point, you can press enter. So it will draw a rectangular element. Same thing you can do for this axis as well. So this plane as well. So once you click the last point, you can press enter. So I've got two rectangular elements perpendicular to each other. So if I zoom this one out, I wanted to replicate this vertical element uh, in the vertical direction, and similarly this horizontal square element in the y direction. So let me show you how to do that. First, you can click this element. So it's in the drawing tool. So I'm going to be pressing escape button. So once I do that, I'm in the selection mode. So I pressed it. Now you can see this area was selected. So I'm gonna go to the option edit, replicate. So what I needed to do is replicating this along Z direction. So remember the vertical direction, the height was 5 meters. I'm sorry if I told you 6 meters earlier. Height was 5 meters, but width was 6 meters. So I'm using 0.5 meter intervals. So in this case, if the height is 5 meters, so that would be uh, 10 elements. So I already have one, so I need to replicate it 9 times. So set 9, press OK. So you can see this one. Yep, That's done. So select the horizontal element as well, edit, replicate. So this one you need in Y direction. So we don't need in Z direction. So it's not 9 times, it's 12 meters. So my interval, so one element is 0.5 meter. That means we need to cover, we need 12 elements to cover 6 meters. So we already have one, and I would replicate 11 times. So we have that as well. Once we have that, I would turn this one and using the pan selection. What I needed to do is, since it's a culvert, so this same vertical elements would be here in this direction as well at the edge of this horizontal element. So I'm going to be replicating that one. So once I selected this one in the 3D view, so you will see all the elements will be selected. So again, edit, replicate. So you will see the direction is Y, it's positive. So it's not 0.5, it's actually 6 meters. So press 6 only one time. You will see it's there. And the same thing you need to do to these elements as well. Yep, a few elements were not selected. Yeah, replicate. It's now is a direction 5 time. That's done. Now in the video which is I have given in the description, I have shown how to calculate the loads, how to calculate the surcharge and soil pressure, and how to apply those. But in this one, I mainly covered how to draw this one from the scratch. But I'll show you just in case if you don't remember how we did apply those loads. So in this one, I will define a sample load pattern as maybe uniform, maybe a self-weight multiplier of 0, add as a new load pattern. So usually soil pressure is increasing when you go down, and there can which is applying in the horizontal direction perpendicular to each element. So you should consider applying all these loads before you replicate in the full structure. Then all the because once you do that, you just need to replicate the all elements. So it will be replicated with the loads. You don't need to apply them again to all the elements. So in this one, I would just apply as uniform loading because it takes time to apply the pressure as an increase in load. But I have done that in the video which is in the description. So for this one, I've selected all these vertical elements. Let's apply, assign area loads, uniform shell, which is now the load acts in y direction, but it's in the negative direction. So I choose y, but I just give a very small number. Okay, so this is, let's apply just -20. Now it's there. Similarly, select these ones as well. Make sure you selected all the elements. Yes. Area loads, surface pressure, sorry. Area load, uniform shell. Now it's y direction, but it's positive. So it's 20. That's done. And similarly, whatever the soil above you can apply. Usually the soil above would be uniform pressure, but in this case, in the vertical, for the vertical elements, I only applied a uniform for the time being, but um, in realistically, you need to apply them in the actual way. Say, for example, it's increasing. So you should select one element. Let's say the first element here has a pressure of 5 kilonewtons per meter square. The next element might have 7 or 8. So you should apply them one by one. So it takes time. But if it's a surcharge load, if it's a uniform surcharge, you can apply like I did. But the soil above would be uniform pressure. So select this one. Some of the elements were not selected. Yep. Can go ahead and apply area load. Now the word it's in Z direction. So let's say it's just 40, but it's in negative direction. Likewise, if there are loads from the road, you can apply them as well. I'm not gonna spend that time over here because it's in already in the previous video. Uh, Now all the things are done. At this point, whatever the loads you have, soil pressure, um, the road above and the soil above, and maybe surcharge loads should have been applied. Unless it's a load from a axle. So we can apply those axle loads later. And what I'm going to do is now I have done the major work. So I'm going to be replicating this structure. Replicate. Now I need it in X direction in every 0.5 meter intervals. So length number, let's say 11 to be 6 meters. Done. So you will see our box culvert. Now, just a quick reminder. So usually the axle loads and all those loads will be applied on the top surface. Um, in the video given in the link shows you how to do that. You can refer to that. I will show how to mm, apply the supports. So we'll go to XY view. So we are in the, the maybe this plane over here. We'll go to the bottom plane. So we usually apply springs because the underneath it's soil. So soil can move, has a stiffness. So I have told in the previous video how to calculate the spring constant. In this one, I would apply the same value. So it's joint springs. I would apply 2000. So this is should be global. Translation global said. So it's 2000. You can see the springs over here in this second panel. For these elements, it would be half of that. Don't worry if you don't get that part, so it's covered in the second video. springs 1000. This would be half of that. 500. Place it. Now it's 95% completed. One thing I wanted to highlight is now the structure is there. We have applied the loads for the time being, but not all the loads. This is just to demonstrate how to model it from the scratch. Once you do these things and correctly have applied loads, one more thing is remaining. It's just that this structure, if you see vertical direction, yes, it does have springs, but in the horizontal plane, if you consider XY, it can move. We need to restrain it. What I usually do is I select 2 points because in the real life, this box culvert cannot move in horizontal direction in X or Y. X or Y, yeah. So we need to make that happen in the computer model as well. So I would select these two corner points, and what I would do is joint, restrain, translation in one and two directions. So that's done. So once you do it, just need to enjoy, go ahead and analyze it. I'll just analyze this for fun and see what will happen. Yep. So I hope that's clear to you how to model it from the scratch. Thank you.